All right, good evening. First of all, if any of you park downstairs in the garage, we have these vouchers here, and you'll only pay $8 with that voucher. So please grab it before you go. Yeah, thanks everyone for joining us here. I will be sharing the slides as well, so you feel free to record anything you want, but I will. This is being recorded, and I'll also be sharing the slides. This may well be the last meeting that I have. December, in any case, we can't have a meeting. The room is not available, and I'm not sure that I can afford the time to do this now that I'm really full-time involved in getting to AGI. So this will be a little bit longer, the presentation. I'm going to be covering some of the ground we've done before, because also according to the Meetup, 2/3 of the people are here first time, so I'd like to welcome you, and also go over the ground that I've covered previously to give you some of the background of AGI. So here we go. So what is AGI? Artificial general intelligence is really a big deal. It's going to be, once we have AGI, it really is going to be bigger than the internet. It's going to be bigger than electricity. And I'll talk about why that is. So, yeah, imagine having an AGI, a human-level AI that can think, learn, and reason the way humans do. That's important. Think, learn, and reason the way humans do. That we can learn interactively. We can hit the books. We can read. We can learn from other people. We can learn from experimentation. We can learn by interacting with the world. So imagine having an AGI that teaches itself. It's not trained. It teaches itself to become a PhD-level cancer researcher, just for example. You can now make 1 million copies of that AGI, and you have 1 million PhD-level cancer researchers chipping away at the problem. Imagine how much will accelerate progress, not just in cancer research, but all the diseases, but also in other domains. Whether it's developing quantum computers or better batteries or energy or whatever. And I'll actually go over that in a bit more detail of what some of the research advances will be with AGI. Now, the second area is kind of more obvious, and that is initially every desk-bound cognitive job out there can be replaced with an AGI, dramatically reducing the cost of goods and services. So whether you're talking about programming or accounting or administration or law or whatever. Now, obviously, the rate of adoption will depend on social factors, whether you have unions going against it or, protectionism or whatever reasons there may be. But from a technical point of view, every desk-bound job, certainly cognitive job, maybe you could want to exclude certain creative tasks, but certainly cognitive jobs. And of course, it will also accelerate the development of robotics. So robots will follow later. At this point, certainly with sort of the early versions of AGI that are likely to be computer-bound or PC-bound, they're not going to be able to replace plumbers and electricians and builders, and because the amount of sense acuity and dexterity that's required for these jobs is simply not there in robots. But ultimately, that will also be developed. Now, the third area that, in a way, is even more exciting from my point of view is what I call a personal assistant. And the reason I double up on the word personal is you own it. You control it. It serves your agenda, not some mega corporation's agenda. And that'll be a game changer, that you decide what it shares with whom. So it's really under your control. You own it. And the second personal is the hyper-personalization that will interactively learn. You're not a demographic, you're not a number. You're an individual that will teach the system, interact with the system, and really tell it what, your history, your goals, your wishes, your preferences, your, who your friends are, and so on. And so it'll really be hyper-personalized, and there are actually two different ways of looking at this. On the one hand, you can think of it as an exocortex, an extension of your own mind and brain, because it'll be able to help you think things through, and it'll be able to do the dirty work for you, like dealing with insurance companies and banks and government and so on. So as an exocortex on the one hand, but on the other hand, it'll also be like a trusted advisor, companion, or think of it as an angel on your shoulder that will help you avoid some of the mistakes that you make in life, to think things through of whether you should get into a certain business or break off a certain relationship, or whatever decisions, make some investment. It'll be able to help you make better decisions. So those are just like three concrete areas, huge areas, that AGI will really dramatically improve our lives and boost human flourishing. Now, in addition to being able to do things at sort of a human level intelligence, there are obviously many advantages a computer has over human intelligence. One of them is it's a lot less expensive than humans in training and employing and so on. Secondly, it's much better at sharing information. So if you have these million cancer researchers, they'll be able to share information much more effectively than humans will. Not just from the point of view that their egos won't get in the way, but also from the point of view that they'll be able to transmit knowledge much more effectively than humans can. They'll be able to work at full concentration level 24/7 without interruptions, without interactions, and probably at a much higher pace and speed than humans can. And they won't have certain distractions, nice distractions that we humans tend to have. So that'll make a difference. And lastly, of course, they also have photographic memory, being computers. They have instantaneous access to really all the world's information that's online, in databases that they have access to, internet, whatever, other tools they can use and so on. And it's simply sort of as simple as thinking of something, like for us, the analogy would be they would have access to that information and be able to incorporate it into their knowledge. And lastly, they are really much better at logical thinking, at rational logical thought. Humans aren't actually very good at that. It's we tend to be prone to a lot of different fallacies and things, and emotional biases. So for humans it's an evolutionary afterthought, the rationality, whereas computers it's very much inherent. So it's a big deal. AGI is a big deal. And when Sam Altman says, we'll have AGI soon, but it's not going to be a big deal. In fact, he said that more recently, this is quote is from January, he actually repeated something like that again just a few weeks ago. He's not talking about AGI. I don't know if he's just confused or if he's lying or whatever. Of course, he has the difficult task, being as visible as he is, that on the one hand he has to tell investors, hey, we'll have AGI soon, give us more money so that we can get you can get a return on your investment. And on the other hand, no, we don't want to scare anybody, that the AGI isn't really going to be such a big deal. But no, that's not AGI that he's talking about. so let me go into a little bit more detail of some of the changes, some of the benefits that AGI will have. And overall, I really see it as tremendously boosting human flourishing in many different ways. So obviously in computation itself, it'll help us get to quantum computers. It'll improve AI itself, and just generally accelerate the development of computing. We don't know yet where quantum computers are going to be useful, but there's a good chance that they will be useful for certain optimization problems, at least if they can figure out how to do the error correcting effectively. I mentioned energy. Again, difficult problems on building better batteries to store energy, which is just such an important aspect of being able to use energy effectively. To build better nuclear power that's safer, to have fusion actually working properly. Again, applying more brain power to the problems will accelerate these developments. Nanotechnology is an area that really hasn't flourished, and for the main reason, not because it's not possible. I think by all accounts, radical nanotechnology, molecular nanotechnology, by all accounts is possible, but it's a really hard engineering problem. So it requires a lot of brilliance. It requires a lot of intelligence and a lot of research to figure out how to build these machines, to build these little, for example, these little nanobots that can go into our bloodstream and clean up stuff, or go into our cells and repair things. Have much better materials like diamondoid materials that you can essentially, build planes, aeroplanes or rockets from diamondoid material, which will be much stronger than steel and yet tougher. So these things are possible, but they require dramatic research. The medical field, well, I don't think I have to elaborate on that very much. Basically ending disease, being able to extend life dramatically, getting cryonics to work, reversible cryonics. Radical things like that can, again, improve and extend human life. Food, being able to, imagine we could have food that's as tasty as the junk food that we get addicted to, but at the same time is healthy. That'd be pretty awesome, I guess. But also to grow food more effectively. Again, these are scientific problems that having AGI, billions of AGI, chip away at figuring out these things is possible. Now, this again is one of my favorite topics, is how AGI will help us with philosophy, basically. I think it's very disappointing what philosophy has achieved over 2,000 plus years. It seems we don't have very good answers, especially when it comes to ethics. We seem to still be in the dark ages, and I think more rationality again will help us figure out how do we determine right and wrong, and other big philosophical questions. And from ethics flows things like governance. I mean, clearly we are not very good at managing our affairs. I don't know how many people really believe that the two candidates we had for president were possibly the best two people we could find in America. Okay, somebody thinks we did? No, okay. Or, you look at the mess in Europe, you look at wars, you look at just the poor decisions that are being made, how we govern how we run our affairs. There have to be better ways that really require rational thought of what makes sense. Now, the reason I have extra P on there is the philosophy, that philosophical movement that was founded by Max Moore in the 90s. And I got quite involved with that, and I really liked the philosophy. It's a pity that it didn't carry on. It just kind of ran out of steam. But the philosophy is about proactive optimism, so a belief that things can get better, but not by themselves, that we have to do something, that, you know, that has to be proactive. So things can be better, but it's not automatic. And it's also about rationality, it's about scientific approach, it's about personal responsibility and personal ownership, so that we have more control over ourselves, but also more responsibility. So it's really a futurism, a positive futurism, scientifically, rationally based, with an emphasis on human agency, and how we can also be free to grow and improve ourselves. So, you know, extra P is basically how we can continually improve ourselves. So I'm hoping that AGI will help to bring about this kind of philosophy and guidance on how we can arrange our personal affairs, and also at the societal level. So I don't know, some of you may be intimidated by the prospect of AGI, but hopefully most of you will also see the enormous benefits that AGI can bring. So when can we have this, and how can we get to it? Now, the when, I really believe that we've already have a taste of AGI with ChatGPT, that in some ways it seems so close, and yet in other ways it's so far. So I think there's probably fair evidence now that from a hardware point of view, we're probably not that far off being able to build AGI. Just the amazing things that, you know, these large language models can do in inference mode, where they don't, you know, where they can do some pretty amazing things sort of in real time on a relatively affordable computer. But in other ways, it's very far away. So I'm going to make the case that we can have full PhD level AGI in a few years, and I'm talking about 3-4 years possibly, but not with large language models. So there's this dirty, not so little, and not so secret that there's a general consensus now that large language models will not get us to AGI. But why I say it's kind of a dirty little secret is technical people know that. There's definitely a consensus. But because of the enormous amount of money that's still flowing in, and companies are trying to raise it, it's kind of swept under the carpet. You know, it's sort of, even the investors know it, the VCs know it, but they don't really want to acknowledge it. It's sort of like, nobody wants to be the first person to say the emperor has no clothes. You know, so let's keep flowing money in, and hopefully the momentum will carry out, and then hopefully we can cash in our chips before everything collapses. That's kind of the mode we're in. But it's, as I say, it's not actually a big secret. Now, Jan LeCun is like a perfect example here, and you know, I quote specifically, he says, large language models are an off-ramp to AGI, a distraction, a dead end. So he's putting it very forcefully, and I agree with him. In fact, he's telling his students not to study generative AI, because that's not what is going to be useful to them. But it's not just him. I mean, you know, you look at Demis Hassabis, the CEO of Google DeepMind. You know, he's been at it for 10 years with unlimited funds. And he says we're going to need something else. Deep learning is not going to get us there, not by a long shot. So they acknowledge it. But of course, DeepMind is doing useful things that they're developing, but they're not really on the path to AGI. And then even, Sam Altman basically acknowledges this as well. So why is that? And I haven't spoken about this before. Sort of something I formulated more recently is what I call the 7 deadly sins of AGI design. So the first one is that there's a focus on knowledge, on having knowledge, rather than the ability to acquire knowledge. And that's a very common misunderstanding that people have about intelligence. They confuse, people who know a lot as being intelligent. And some of the IQ tests out there actually reinforce that, where they're kind of too much knowledge-based. And I can share a personal anecdote of the difference here. I lived in Africa for many years, and sometimes you'd come across people who grew up on the farm, in some remote place, didn't have electricity, never seen a car, definitely no TV or, computers or anything like that. This is, a few decades ago. And they come into the city, and the intelligence would allow them to very quickly find their way around and learn about the big city, to learn about electricity, about cars, about traffic laws, and all these things they simply didn't know. That's the measure of intelligence, is to be able to learn interactively, to learn quickly, to generalize, to learn things and figure out where they apply, where they don't apply. That's what intelligence is. It's not about having massive amounts of knowledge. So any AGI design that doesn't focus on the acquisition of knowledge and how to generalize is on the wrong track. Narrow instead of general, pretty much the whole field of AI has been narrow AI. When the term AI was coined 69 years ago, they originally thought that it was about building thinking machines that can think, learn, and reason like humans. That was the original idea of AI. And they thought they could crack this in just a few years. So of course it turned out to be much, much, much harder. So what happened, the field of AI really turned into the field of narrow AI, where they picked one particular problem that requires human-like intelligence, human-level intelligence, and then use human ingenuity to figure out how to write a program to solve that problem. So, perfect example here is IBM's Deep Blue. World chess champion. It's the ingenuity, the intelligence of the programmers to figure out how to write a program that can play a mean game of chess. It's not that the chess program itself had the intelligence. It couldn't even figure out how to play checkers. And this is still, even with large language models, that is true. Now, of course, it's a much broader range when you have a large language model that has general language competence. But why is it that every real application that you want to apply these to, these sort of agentic systems, require an enormous amount of human intelligence to actually get them to work? What training data to give them, how to set up the RAG, how to do the prompt engineering, how to tweak the parameters, and get everything to work. And then if something changes in your business, you have to go back and fiddle again with things. So there isn't the autonomy. So we're still in the sort of narrow solving one set of problems at a time. So the next one is external control instead of autonomous. Sort of pretty much covers what I just spoke about. It's the programmer or the data scientist who's really doing the magic to get the intelligent thing to work. Pre-trained instead of incremental real time. It's somewhat related to the first point, but you cannot have intelligence that is read-only. And that's what large language models are. They are read-only. Otherwise, they wouldn't have to throw away models that cost hundreds of millions of dollars or even billions of dollars. They wouldn't have to throw them away and start from scratch again. They have to be, you know, you can add with rags, but that's external. You can put something in the input buffer, but it's not integrated. The core model itself is read-only, cannot be changed. In fact, I have a white paper on that, where I was co-author we reviewed recent attempts for people to have incremental learning added to large language models. We surveyed more than 200 papers that are referenced in our white paper. There's not a single one we could find that actually manages to update the core model. They all do external training or maybe do fine-tuning on the last layer or something, but the core model cannot be updated. That's not intelligence. If that's how your system is designed, it cannot get to AGI. Quantity of data instead of quality. You know, we now have 20 trillion pieces of information, good, bad, and ugly. You know, and a lot of ugly because just get data from internet and so on, and the system doesn't know what's good and what's bad and what's ugly. So really, if you want a human to be effective and intelligent, you also make sure that they get good information and not bad information, and especially that they kind of have some idea on how to figure out the difference. Statistical instead of ontological is a bit more of a technical issue. So large language models do in fact form concepts of a kind that basically the vector representation is essentially similar to a concept that we form in our heads. So you can kind of find, you know, the famous thing there is that you have a vector for queen and king, and you know you subtract male and add female, and you get from king to queen. The problem is that the vector representation in large language models is based on statistics on word co-occurrence. It's not based on ontological considerations. So a proper AGI system, the vectors, first of all, they need to be variable, not fixed size. So as you learn more and more about a certain thing, you'll keep adding dimensions to your vector. So the vector dimensions need to be dynamic. And secondly, you want your vector dimensions to represent things in the real world, to be grounded essentially. So that's what ontological means. Give you a simple example that, you know, if you form a concept of dog or cat or cookie or table or whatever, you want the vector dimensions to represent the attributes of those entities and not how close they are. In fact, one of the examples when we started trying to use a word to use vector representation, statistical vector representations, we found that dog and cat were closer in vector space than dog and puppy. You know, and things like that. It's because it's not an ontological thing; it's a statistical correlation. Well, and lastly, basically, the approach of building AGI, if the approach is, hey, we've got a lot of data, we've got a lot of compute, that's the hammer we've got, what nails can we find? That's basically, there's no inherent theory of intelligence behind it. It's just, hey, this happens to work pretty damn well, and we can make money, and we can raise more money, and they've been incredibly successful. You know, I definitely don't want to take that away. I mean, how we used to struggle with speech recognition, you know, it's dramatically improved with these, you know, with deep learning, translations, image recognition, and so on. It can obviously do a lot of really amazing things. But if you're trying to build AGI, I think you really want to start with the question of what is intelligence? Let me understand intelligence. Let me understand what's special in human intelligence, and build a theory around that. Start with a theory of intelligence to then build a system that encompasses these requirements. And I'll talk a bit more about that. Now, LLMs fail on all of these. So probably this is the biggest killer. As I mentioned, right now, they're throwing away large language models that cost hundreds of millions of dollars and projected to be $100 billion even, or certainly billions of dollars. Elon Musk just spent $5 billion building a data center. Now that's going to be obsolete probably in 2 years' time when been better chips and so on. So how many models is he going to train in 2 years? I don't know, 6, 8 maybe. So each model will cost something like $500 million. Now I think for Tesla that's probably okay, because if they can get full self-driving to just get good enough that they can actually deploy it, and I have a Tesla, I think it's fantastic and all that, but it's definitely not full self-driving. But if they can get it to a point where it's robust enough, that's probably worth $5 billion. But for all of the other players out there doing large language models that really don't have anything distinguishing, they don't really have a significant competitive advantage, to build models that cost hundreds of millions of dollars and have to be depreciated in like 4 months or something, how are you going to make the numbers work there? You have to throw them away. And they clearly have to throw them away, otherwise they would just keep retraining them, adding to them if they could learn incrementally. And this is the title of this particular talk. Sort of the pivot point, I think the most obvious thing that one can say of why the current LLM approach is really nuts is, the kind of money they're talking about. I don't care if we burn through 50 billion, 500 billion, give me $7 trillion. We don't have a plan on how to get to AGI, but just, if we build nuclear power plants, recommission power plants and build enough chips, and somehow the magic will happen. It's actually, let me skip through that. So, I think we've already established that. Transformers. The only point I want to make here is, GPT-P is pre-trained. G is generative. It makes up stuff, and that's inherent in the design. And transformers is really the breakthrough technology that made these so powerful, but at the same time transformers commit you to pre-training. Transformers require backpropagation. They require all of your data to be available up front and to number crunch it millions of times to create the model. So GPT really commits you to this approach. And the external guardrails and things that you put around to actually make them acceptable and practical. I've seen applications, commercial applications, where there's so much external stuff in terms of prompt engineering and external guardrails, logic systems that you add, RAGs and whatnot, that you really need to ask yourself, there's a tail wagging the dog, Do you really need a large language model to solve that problem, or is it just like the shiny new object that you can get funding for? So, that's basically where we are. We're trying to build bigger ladders to get to the moon, or bigger airships to really have transatlantic flight and so on. And we really need a different approach. So what people are talking about, the most common thing is to somehow have a neurosymbolic approach, or to have a symbolic system, to have a logic system that can somehow tame the LLM. And of course the first step is in trying to do that with chain of thought, but I think people are seeing that still has a lot of the limitations of large language models. You really want something more robust. So you also, I haven't spoken about this up to now, is basically system 1, system 2 thinking. I think probably most of you are familiar with Daniel Kahneman's System 1, System 2. System 1 is basically our automatic subconscious thought that we do, that we have, and then really what makes humans special, what makes human intelligence special is that we have metacognition. We can think about our thinking, and we can think symbolically. Animals cannot do that. And, we can switch between these two modes automatically. So, if you're a competent driver on a road, you're really an automatic pilot. It's your System 1 taking control. But then something happens, something unforeseen happens, System 2 kicks in, and you start thinking about how you should deal with the situation. So that's kind of a good example of System 1 and System 2. So that sounds promising, is to have the advantages of a neural system which doesn't suffer the brittleness of symbolic systems, and yet have symbolic systems that can do kind of the reasoning. So the problem is that you really need a uniform data representation. You cannot have two separate systems, a System 1, System 2, because you need to be able to switch between System 1 and 2. They're really not in our brain, they're not separate parts of our brain. They're just logically, whether you're consciously aware of it or whether your symbolic processing is doing the heavy lifting or not. So you need a uniform data representation, and people haven't really figured out how to do that. I mean, if you take a large language model, it has its data representation baked in. You take a logic system, and that probably has some kind of a graph database or something of that nature. The vector encoding problem that I spoke about, that is not ontological, that's a problem. And then you still have the problem of real-time learning, that basically maybe your logic system can learn in real time, but your large language model can't. So now we talk about what I believe the solution is, and it's not $7 trillion. It starts with first principles to talk about how does human intelligence work. So first of all, our brain uses 20 watts or somewhere around there, not 20 gigawatts. We don't need a nuclear power station to learn stuff and learn language, learn reasoning. And we also don't need 20 trillion pieces of information to learn. A child can learn with probably something like 2 or 3 million words, can learn language and reasoning. Okay, there's more to it. Obviously a child interacts with the world and so on. So, don't want to be too simplistic about it, but clearly it's fundamentally very, very different in terms of what human intelligence requires. So imagine we could have this kind of approach. So how do we get there? DARPA gave a presentation a few years ago that they called the 3 waves of AI, which I find very, very useful. So the first wave was basically what we now call good old-fashioned AI. Those were all the sort of expert systems, logic systems. Again, Deep Blue would be a good example of that. And we now, of course, are surfing the second wave, which is, big data, statistical systems, and now generative AI. So to get to AGI, I believe what we need to do is to work on the third wave, which is inherently adaptive systems, which means real-time systems that can learn in real time. And a good way to describe that is to call it cognitive AI. So it starts with understanding cognition. So I think I've already pretty much, flogged this enough of what is so special about human intelligence. But one really needs to take this seriously. The ability to learn interactively in real time, to be able to form concepts and to apply these generalizations contextually. That what you know in one domain may need to be applied differently in a different domain. So that's kind of the issue of transfer learning. And we need metacognition. We need to be able to think about our own thinking. We need to be aware of our thought processes and be able to control and adjust them, at least to some extent. So again, I've spoken about this, the difference between having knowledge and acquiring knowledge. You know, if on the left-hand side, if you think of that as the knowledge you've already acquired, knowledge and skills, the really important thing is on the right are the set of skills that enable you to learn other skills and enable you to acquire knowledge. So if you build a system that focuses on the right-hand side here, on those learning algorithms, then I think you're kind of on the right track. So external intelligence versus being able to acquire it by itself, fixed versus adaptive, and you know, narrow, yeah, and basically autonomous learning. So that's where we want AGI to be fully adaptive and not to need the human in the loop. You know, like we can learn largely by ourselves. We know when to ask for help, and we can basically hit the books. And this, I think, very nicely shows the difference between the approaches. Where generative AI, the focus is on having knowledge and skills. And in fact, the knowledge and skills are way off the chart there compared to human level. I mean, what large language models encompass is, you know, orders of magnitude more than any human can have. And yet they don't have the power because they are very weak on the axis that represents the ability to adapt and learn in real time. So the way we do it is basically that we focused on having a small set of fundamental learning mechanisms. If you think of how the brain works, it doesn't have super fancy algorithms in it. It has a few dozen very basic mechanisms. I mean, the most basic one is Hebbian learning, fire together, wire together. It has ability to learn patterns, to generalize patterns, and it has a few very basic functions that are implemented in our wetware, and that's kind of the approach we have. Is some to have these the correct learning mechanisms. No backpropagation. Our brain doesn't use backpropagation, at least not to any significant extent. That, in fact, I don't think it does, but there's some debate on that. We implement this on a knowledge graph, so the common representation between the neuro and the symbolic is basically the common denominator is a graph database. So the graph database allows you, it's a vector graph database. So the vector graph database allows you to represent things in vectors, which gives you the kind of fuzzy matching ability and the flexibility, the non-brittleness of vector representations, but the knowledge graph, on the other hand, also gives it's not a black box, and it's an overall cognitive architecture that basically has a knowledge representation together with the relevant cognitive mechanisms to learn and to reason. We don't try to be an oracle, something that knows everything about everything. That kind of doesn't make sense. I mean, it's with large language models, it really just happened to be that the only way it could get language competence is by having massive amounts of information, which that's just the way it happened to work out. You can't get language or reasoning competence without having 10 trillion pieces of information. At least people haven't figured out how they could train an effective large language model that doesn't have as much knowledge. So it's kind of just a byproduct of the technology, but you really it doesn't make sense to build an AI or an AGI that tries to know everything about everything, because you can't be an expert at everything, and you can't keep everything updated, the knowledge. You really want specialists. You want generalists and you want specialists. So That's our approach. Now, it being a powerful tool user, again, was one of the things that defines humans, is that we are tool users, we are better tool users. And again, an AGI will be an excellent tool user. So if it needs to play a game of chess for some reason, it can use a chess computer for that, or chess program for that. If it needs to write a poem in the style of, I don't know, Bob Marley or something, it could use an LLM for that, So it can use tools and use specialists as needed, rather than, trying to be an expert at everything. Now, cognitive architectures, we consider ours a cognitive architecture, third wave of AI. Why haven't cognitive architectures taken off? If that if the approach makes so much sense, and I'll talk a bit more about why that is later on, but specifically cognitive architectures traditionally have a number of problems. The one is people have engineered them to be very modular, which is a reasonable approach from an engineering point of view. As a good engineer, you try to make things modular. The problem is with cognitive architectures, you ended up with components that didn't really talk to each other. So, for example, you might choose to have a parser. So you might say, well, what's a good parser? A Stanford parser. Okay, we'll use the Stanford parser. You have the Stanford parser module. You need a reasoning engine. You'll use somebody's reasoning engine. You need a data representation. You'll use something else. And these components don't talk to each other. They're not integrated properly. And so that's been one of the reasons why they haven't worked that well. They also haven't had much love in the last 15 years because all the oxygen has been sucked out of the air with the success of large language models. So very few people have been working to try and improve the cognitive architectures. The other problem that the thing that we solved that was kind of key to a key breakthrough is we designed our own vector graph database that is literally 1,000 times faster than any commercially available graph database. And I have a white paper and the tests there for that. So it's custom designed for the purpose, and it's 1,000 times faster. So if our system can respond in 1 second, which is kind of a reasonable, way to have an interactive system, and you use an off-the-shelf graph database, you're talking about 1,000 seconds now. You can't really do anything with that. You can't run tests. You can't teach the system or do anything. So first of all, we have a super high performance knowledge graph. And secondly, all of the cognitive components were designed from the ground up to be deeply integrated with this graph database and with each other so that they communicate and support each other. So as the system is trying to make sense of an input sentence, it essentially has access to the reasoning part of the system to see if the particular pass actually makes sense. It has access to short-term memory, long-term memory. They're all deeply integrated. So specifically our approach to get to AGI that we've chosen is to train the system like a child from the ground up. That we actually believe it's important for the system to learn language and reasoning from the most foundational aspects and concepts. The most common, the most robust things are learned first and can then serve as a foundation to higher levels. And that is how we're teaching the system. So it's essentially an agent that lives on a computer, has access to the desktop, so that's its vision. It has eyes, it can see whatever's on the desktop. It can sense mouse movements. It can control the mouse, keyboard input or voice input, whatever. And of course it has also text output. So text input, output, and mouse. And the idea is to basically teach the system, focusing on building a curriculum that most effectively teaches the system language and reasoning the way you would a child. And so, we're going from 3-year-old to 4-year-old to, 10-year-old, 16-year-old. And at a certain point, as you go along this development, it will require less and less teacher assistant, because, by the time you get to, a motivated 10-year-old, it can really hit the books and learn largely by itself and know when to ask for help. At the 3-year-old level, we are very much guiding the curriculum. So we look at that as seed AGI, that at a certain point, the system will really be able to improve itself largely autonomously. Now, what follows from that is also seed AI in the sort of singularity sense, that yes, at a certain point it'll be able to do my job better than I can do it, and it'll be able to improve its own design. And now, I don't believe the singularity from the point of view that we're going to get to an infinity. I think that's nonsense, because reality is much more complex than any computer system will ever be able to fully control. And we actually know that most problems in the real world are actually chaotic systems. We also know from quantum mechanics that the limits of knowledge that we have. So we know from several sources that dynamic systems in the real world cannot be predicted. It's impossible to predict them. And basically the complexity grows much faster than any computational system can. So it's not that we're going to have infinite, we're not going to have godlike AGIs. There's no such thing. That's just, sort of theoretical misconception that the system can just infinitely improve itself. It'll hit the limits of what is the optimum size of a computer that is most effective. Now, that intelligence is going to be significantly above human level intelligence, but it's not going to be, infinite or godlike. So, but we are right now we are concerned to get our system to be able to learn by itself more and more, and that's not a simple task. Anybody recognize who that is? You know already. Well, if you've been here before. Yeah. Okay, that's Helen Keller. And she was deaf and blind, and she learned through sign language, and incredibly intelligent woman. She wrote autobiography and read all the great literature, and certainly super intelligent lady, but with very limited sense acuity. And then of course we have Stephen Hawking, who had very limited dexterity and also super smart. So that's kind of the way I look at AGI. To try and do everything that humans can is really, really hard, especially when you think about robotics. So I try to simplify what is the minimum we can do to build AGI. And so that's basically the Helen Hawking theory of AGI. How can we have very limited sense acuity and very limited dexterity, but still have full human level intelligence? And this goes back a long way. In fact, the t-shirt I'm wearing is kind of my business plan from 2001. So I've been working on this for a while. On the back of a napkin, so we printed some t-shirts. 24 of them, they're numbered. And basically the idea is, what's human intelligence? Understand that. How can we make it as simple as possible? What is the core requirement? And then basically build a prototype, commercialize it, build a better prototype, commercialize it, until we get to AGI. So it's taken a little longer than I thought it would. With various distractions, but that's kind of a key aspect. I'd love to be able to build AGI with robotics. Have a system that can actually learn interacting with the real world, but you spend all of your, first of all, robots aren't powerful enough yet, but secondly, you spend all your time fixing mechanical things, you know, and you can't speed things up and learning and so on. So that's why we chose to sort of this Helen Hawking model of AGI. Just another reference to white paper. This is one of the other key insights, is the importance of concept formation in human intelligence. So one of the key differences, one I mentioned, is that animals don't have metacognition. They can't really think about their own thinking. They can't think symbolically. But there's also another big distinction, and that is concept formation. Animals cannot form higher level concepts. Animals can only form concepts that are directly tied to perception, or very closely tied to perception. So they can, you know, categorize a food bowl from, I don't know, fire hydrant from, you know, tree or whatever, but they cannot form higher level concepts. Now, with humans, we can form concept on top of concept. So we can basically do this concept formation recursively. We can take concepts and form higher level concepts of that, and up to pretty much an unlimited degree, to very, very abstract concepts such as, you know, honor and government and marriage and things like that. So this is just a representation of how concepts are formed and how that works. Here's just a list of the core cognitive mechanisms that we've built into the system. As I said, the brain only has a few dozen fairly primitive mechanisms for learning and generalization. And these this is an overview of the things that we've implemented in our system. So it would be obviously short-term memory, it would be instance learning, it would be generalization, pattern recognition, pattern matching, prediction, you know, things like that. And these are some of the data structures, the vector data structures that represent the different knowledge and skills and relationships that need to be encoded. So who's working on cognitive AI? Well, hardly anybody, basically. And that's an accident of history. You know, it's really that large language models have been so successful, or deep learning has been so successful over the last 15 years. It sucked all of the oxygen out of the air. It's really the only game in town. It's a monoculture. If you want to get a paper published, it's got to be something to do with deep learning or now generative AI. You want to get funding for something, you want to earn the big bucks, you know, it's the only game in town. So it's literally it's very, very hard to get anybody interested. And now we actually have a whole generation of computer scientists that don't know anything else. So it's sort of even a dying science. Around about 2000, cognitive science was actually pretty prominent. And cognitive science is basically the intersection of philosophy, you know, understanding epistemology, theory of knowledge, and, you know, what is free will and consciousness and things like that, understanding the mind and the brain from that perspective. So it's the intersection of philosophy, cognitive psychology. You know, what do IQ tests measure? How do children learn? How does our intelligence differ from animals? And the various experiments that have been done in that. And then, of course, computer science. But that multidisciplinary intersection, you hardly find that now. So it's very hard to find people that have knowledge, interest, or that you can get funding for. Intel have a project internally, a research project, but Intel is also famous for their projects, internal projects, not going anywhere commercially. Elemental Cognition, run by Dave Ferrucci. He was actually one of the key architects of Jeopardy Watson. and I chatted with him last year. He has some of the same ideas of cognitive AI. Unfortunately, his company was funded now by I think a hedge fund or anyway, financial institution, and all they're interested in is for him to use his technology to pick stocks or do stuff like that. So he's a bit frustrated. He's certainly not working on AGI. Yes? So,
They just went bankrupt.
what is it?
They just went bankrupt.
They went bankrupt? Oh wow, that's news to me. Oh, that's sad. That's very sad. Okay. Definitely should talk to him again. Has good ideas. And then, of course, our own company. Over the last 20 years, I've never. I had a commercial company that was fairly successful. We grew to 400 people, did an IPO, and that was great. This was pre-AI, to the software company. And so I had some money to start working on AGI, but not enough money to really hire the kind of team that I needed. So we needed to pivot to commercialize our technology. And so 5 years went by commercializing, building a commercial company. Also ended up with investors that weren't really interested in AGI, so we sold that company, started another development company, which is now IGO. Again, we got to a point where we had good technology, but couldn't get investors to fund AGI development. So we again commercialized, and we were quite successful. One of our well-known customers was 1-800-Flowers, Harry and David group of companies, about 12 companies. And at last Valentine's Day, just this year's Valentine's Day, we actually replaced 3,000 agents that they normally had to hire for just 1 week, or Valentine's Day. So our technology was able to very successfully automate that. But again, our commercial version of it is much more narrow AI. There was a huge amount of handcrafted rules, business rules, and language capabilities, and so on. That's just, and basically you fall into the narrow AI trap that, if you're trying to build AGI and you try to then commercialize an early version before you actually get to human level, you basically end up hard coding a lot of stuff, and you really, your focus shifts. And the same thing is if you're trying to beat certain benchmarks. Like we have the ARC challenge now. If you wanted to do the ARC challenge, you'd be hard coding a bunch of things to try and beat this particular test, to this particular benchmark. So you're trying to get papers published, then you try to tweak things to have some interesting results in the short term. So it's very easy to fall into this narrow AI trap of focusing on a subset of sort of things that seem intelligent or are interesting, but you're not really working on the core things that you need to work on. So our commercial brain, to concretize that, the actual knowledge graph is the green part. That's the dynamic part, the system that could be dynamically updated and learn in real time. But then we also had a lot of language rules and reasoning rules that were handcrafted. So we basically had a rules engine and rules that our engineers and cognitive AIs, we call them AI psychologists, crafted these language rules and reasoning rules, which is not the way it should have been done, but to expedite functionality, we did that. And then more things were done in code than should have been done in code. And so now when we decided to put our commercial business on hold, we basically stripped out all of the rules, minimized the amount of code we have, and added vision to our system, because for the commercial side we didn't need vision. So we really, in a way, starting with a clean slate to build AGI now that doesn't have any of the handcrafted rules, minimal code and vision, and that's basically what we're building now. So the focus is on building up the curriculum to teach the system. First milestone is sort of 3-year-old language and reasoning capability, and then we plan to scale up from there. This is also an interesting thing that I'm not sure if I shared this here before, is the way the system is designed, and our commercial system was designed like that too, is the red circle represents the general knowledge that the system has. So that's ultimately, when we get to AGI, that'll be sort of a college graduate level of general knowledge. It has good language capability, good reasoning capability, and general knowledge, knows how to use tools, knows where to find stuff, and so on. And then the blue layer is basically the specialization. So that's the part that would be your PhD level cancer researcher, or your programmer, or your accountant, or whatever, where it then specializes in a particular area, or specializes in being a generalist, knowing a little bit about lots of things and being able to coordinate things, or managing administration, whatever it might be. And then the green layer is the individual personalization. So the best example there is, of course, the personal assistant. So the green layers, each user will then personalize the system. So the knowledge it has about you is represented in the green layer. So logically, these are not physically different layers, they're just logical layers in the knowledge graph. Oh, yes, I pressed the wrong button. Okay, so this is kind of an overview of our business plan. Here is the core system, the actual learning, the knowledge graph, the vector knowledge graph. We cleaned that up from our commercial system and basically improved that. And then the core learning algorithms that we have and the way we encode things, that's pretty much the work we've done now. We're focusing on getting the language and reasoning ability of a 3-year-old, and hopefully that'll already kind of make it interesting enough for us to be able to get some more funding to increase our team significantly. And then really what we consider as financial escape velocity, we think is like 10-year-old. I think by that time it'll be that obvious that this approach can actually get to AGI that we'll have to beat investors away with a stick. So that's kind of the plan. And what we bring to the party is initially I spent 5 years just doing my own research and deeply understanding intelligence, studying philosophy and psychology and computer science, and spent 5 years doing that to really come up with a theory of it. And then the various companies we have, the experience we've gained in building prototypes and commercializing it and so on. Hopefully that will, convince people that we actually have an idea of how to build cognitive AI. And then, as I say, we believe we can get to a 10-year-old within 2 years, given more funding than we have now. And after that, it'll be very, very quick, actually, to get from 10-year-old to get to production-ready systems, to commercial systems. So I think I've already spoken about that, so I don't need to elaborate. I have an article on that. So I think well, it should be no secret to you by now that I think that AGI is going to be tremendously beneficial to humanity, and probably in the Q&A, I'm sure usually the questions come up, isn't AI going to kill us all? Obviously, I don't believe that, for I think good reasons. So we really need, I think there's a good argument to be made that it's more likely that we need AGI to save us from ourselves. That the way humanity is progressing, we seem to be doing a pretty bad job at managing the sophistication of modern life. So I think there's good argument that we need more intelligence, that we need AGI to save us from ourselves. That's sort of the argument. But even if it isn't that, it's basically just the tremendous benefits that AGI will bring is for us for human flourishing, to foster human flourishing. Yeah. Imagine, instead of the insanity of large language models and companies getting seed funding of $1 billion at a $3 billion valuation with no product, no moat, no revenue. Maybe people should invest in a real path to AGI, whether it's our particular path. There are some other ideas floating around there, but to really take seriously, what will it take? What is it like? What will likely get us to AGI in the quickest way? So, that's a take-home message. If you can spread the word on that, for people to really just take off the blinkers, get beyond this monoculture, this insanity of large language models. Yeah, there is clearly a lot of money around. There's a lot of interest, and as I say, large language models have given us a taste of that. So, yeah, spread the word. Anybody who's interested in helping make this happen can contact me, and hopefully we can expedite. Thank you. So I'm sure we'll have some questions, but let me just get some water. All right. Questions? Yes?
Yeah. So early on one of the slides you had your earlier work, which you had a bunch of AI on top, and then you rule-based, and then some other stuff on the bottom, and you recently wiped the table with that and put a bunch of stuff in vision, because, babies can't breathe, right? But they do have eyes.
Right.
So given that, logically, your next step when you talk about the robotics is you say, well, babies have bodies, so we got to go to robotics. Book learning is ridiculous. We figure out how to use the robots first.
Yes, I think just in case people didn't hear it. So we've added vision back now. In fact, our early prototypes had vision as well. So we've added vision back because you need some sensors. So shouldn't we be adding robotics back? So really the argument there is the Helen Hawking theory of AGI, that you can have a system that has a high level of intelligence but has low sense acuity and low dexterity, to basically make the problem simpler. Because high sense acuity, first of all, we don't have anywhere near the senses that humans have. I mean, robots aren't anywhere near that. Simply don't have that. But it's also extremely difficult to work with robots. It's very slow. You can't speed up the learning process. So, if it was necessary, theoretically, it seems it's not necessary. Helen Hawking, So you can have that intelligence, and that intelligence can then help us solve the robotics problems. So that's really the argument. What is the minimum? You know, that's on the T-shirt here. What's the minimum we need to build something that has human level intelligence? Because we want to make it as simple as possible. It's a really, really hard problem. You know, one of the things we're struggling with, and we're going to need some, you know, a few $1 million to throw at that, is vision is not a solved problem by any stretch. You know, computer vision is not a solved problem. So a modern desktop, the amount of complexity you have on a modern desktop to basically make sense of that is quite intimidating. So what we're doing now in the early phases of our development is we sort of using more like whatever the version 1.0 of Windows was, that kind of resolution, so that we can deal with a lower resolution, you know, graphics and vision right now, because if we can get that to work, yes, you can scale it up, but you know, it'll take some tricky engineering to scale it up, and for that we need more money. So it's really what is the minimum we can do to get to a PhD level researcher, you know, or programmer or accountant that can learn autonomously, can hit the books basically. That's really our focus.
Makes sense.
Yes.
So those benchmarks that your company has set of like being at the level of a 3-year-old, being at the level of a 10-year-old, I imagine, or please correct me if I'm wrong, that's against the curriculum that you're defining. This is the curriculum for a 3-year-old, this is the curriculum for a 10-year-old. So like a 10-year-old learning something can only interact with that thing so many times in a set amount of time. So like they can only study for a few hours a night, for example. Are you putting those same constraints on your system? Like it only has so many examples to pick up the concept?
Yeah, so basically if I understand correctly, how the curriculum, how the teaching changes as we go from 3-year-old to 5-year-old to 10-year-old, and can it learn continuously? So a couple of points there. In fact, half of our staff in the company, we call them AI psychologists. They're not programmers at all. They typically have a linguistics, education, or cognitive psychology background. And so their task is to understand the mind of the AI and to come up with an effective curriculum. Now, the curriculum for an AGI is actually very different from a child. I mean, a child has a motivation to play and get food and love and whatnot, whereas the AGI doesn't need any of that. You know, it's programmatically motivated to learn, and it can learn basically 24/7. Doesn't get tired, you know, doesn't throw tantrums, you know. So you can teach it much more effectively. Now, one of the things that we haven't actually implemented, but I'm sure we will implement, it's sort of on our roadmap, is a sleep cycle. Because clearly we do a lot of cognitive integration while we sleep. Seems to be I think there's a lot of evidence that during sleep we consolidate knowledge that we've gained. And so as we go through the curriculum and we basically teach it things and then test it. You know, so we do teaching, testing. We basically test whether it understood what we taught it and whether it can generalize the information. That we go through these cycles. But there's only the amount of generalization and consolidation that is sort of immediately obvious that comes out of that. So I think we'll need a sleep cycle where the system basically doesn't get any input but can just kind of see what parts of the knowledge graph are contradictory, or where it can go to a higher level to find generalizations. So that kind of sleep cycle is something that, as I say, is part of our development path, but we haven't got to that yet. But we see the system being able to learn, basically can force feed it. It can learn a lot of information much more quickly than a human can. So we're not going to need 20 years or 15 years or something to get to PhD level. Be able to get to it much quicker. But the way the training will change is, even as we get from 3 to 4 to 5-year-old, there'll be a lot more questions that the system will ask. I mean, like children, why? We want our system to basically recognize gaps in knowledge where we teach it something, but it isn't quite enough. It doesn't quite make sense. And where the system will then let you know that it doesn't understand something or that it's missing certain knowledge. And that's on the path to autonomy, that the system becomes more and more autonomous in learning stuff.
Well, yeah, you're trying to teach a skeptic. Basically, you're trying to make a skeptic.
What is that?
You said you're basically trying to make the AGI be a skeptic of its own thinking.
Yes, yeah. Well, actually, in terms of, I very much like what Elon Musk says in principle, that he wants Grok to be truth-seeking. And it's an obvious thing that an AGI should be able to do. And so we definitely will be training and tuning our system to be truth-seeking, because, things that are contradictory, it should automatically always have a drive to say, well, I learned these two things, but they can't both be true. So can I resolve that somehow? Can I understand that? So that is definitely something that is key to our approach.
A quick question.
Yeah.
You had mentioned kids, right? So I'm in accounting, and software development. We're trying to automate tax preparation and accounting completely, right?
Mm-hmm.
I'm having lunch with my daughter. She's in cybersecurity. She's 16.
Mm-hmm.
And I'm explaining to her what we're working on. She's like, man, Dad, you know what? You sound really excited about this, but can I tell you something? She goes, don't forget the human element.
Don't forget what?
The human element of it, right? And so I start thinking about what she's saying. It's like, okay, well, if it does get built out the way you intended, what kind of effect is that going to have on society as a whole? And is that something that you have even, with the philosophers and everything you have on staff, have you even looked at that? Like, what kind of effect is essentially taking a PhD level entity, putting it in a domain, letting it go wild? Like, what is that? How is that going to affect everybody in a room? I mean, yeah, the human nature.
Yeah. Well, AGI.
And how do you, what's the commercialization of it? Like, how does it, I guess, do you understand what I'm trying to say? Like, how does it, I understand the technology.
Yeah. So AGI will have a profound effect on humanity. I mean, there's no doubt about it. And unless civilization breaks down before we get to AGI, which is likely to happen, AGI is likely to happen, as I say, I can't see it being more than 5 years, because other people will cotton on to what the right approach is. That's becoming more and more obvious that you need something other than large language models. So I think there'll be more effort. So unless civilization breaks down before we get to AGI will have a profound effect on us. And this is part of the reason why, to me, it's so important to have this personal assistant that everyone in the world can have. And the kind of financial partner we're looking for is somebody who'd be committed to that. So that we have this angel on our shoulder, this exocortex that can help us, help guide us through this dramatic change. But clearly there'll be massive unemployment, and that's a flip side of having a massive reduction in the cost of goods and services through automation. But the way to think about that is not to focus on the unemployment, but to flip that, to do jujitsu on it and kind of flip that on its head, and say, well, if you talk, if I ask people here in this room, or if you ask other people, would you like to win the lottery? I mean, most people will say, oh yeah, I'd love to win the lottery, then I wouldn't have to work anymore. I could still work if I love the work that I'm doing, but I wouldn't have to, and I'd probably be spending a lot of my time doing other things, whether it's family or whatever, learning something, art or whatever it might be. In fact, I suspect that a lot of people will have to work much fewer hours to be able to afford to live well. I suspect that a lot of people will actually be motivated to help the rest of the world be uplifted. Again, I lived in Africa for many years, and an incredible amount of work that needs to be done to bring Africa up to the standard of living that we have, in the US and Europe. Same many parts of Asia, India, and so on, the same thing. So I see a lot of us will probably want to spend time to help uplift people in the rest of the world, to bring the technology there. But it'll be a profound change, and but I see AGI helping us to cope with that change, because they'll also be good psychologists. That'll be one of the skills that an AGI will have. It'll be able to know how to help people cope with, kind of difficult situations. So, yeah, it's going to be a big change. Now, how quickly AGI will get implemented, I don't know. There's going to be a lot of resistance from governments, from unions, from, we just saw this ridiculous situation where in America we can't have automation in the harbors. Part of the union settlement, and I don't know if the final settlement included any automation at all, but it's totally ludicrous. The power of the unions to just stay stuck in the past. All the pollution that it causes, and the extra cost and so on. So I don't know how, but there'll be parts of the world that will benefit from AGI, and which parts of the world will be left behind and not benefit because they'll outlaw it, or whatever. It'll be interesting to see. So I don't know the answers, but AGI will help us cope with these things as well. There were a bunch of other questions. Yes.
So you talk about kind of PhD level intelligence, and you have spoken about psychologists and all that kind of stuff. Have you felt the need to teach emotional intelligence, and if so, what does that look like in the whole curriculum setting?
So emotional intelligence, do we have the need for that? For the system to be able to understand emotional intelligence, I think we need to have more of the metacognitive parts working, which we at the 3-year-old level we don't have much metacognition yet. It's at the moment the metacognition is pretty primitive. It's sort of when am I surprised? When am I uncertain? It's sort of uncertainty and surprise. So it's not super sophisticated yet at this point. So I see that happening at a higher level, and the thing I just mentioned here is I see an AGI also being an excellent psychologist. That'll be part of the training to be exposed to be a good personal assistant. It has to have that kind of ability to read people, to understand them, to understand their cognitive state, and to be able to respond appropriately. So when, remember we looked at those 3 circles, the red circle in the middle. I see emotional intelligence and sort of related things to be part of the core competencies that every system should have, irrespective whether, they're personal assistant or whether they're customer support or whether they're accountants or programmers. That ability to effectively interact with humans. So yeah, emotional intelligence will very definitely be part of the curriculum and of what the system needs to know. But emotional intelligence is, I see it as, from a computer point of view, I see it as a cognitive skill, not it's not going to be emotionally driven the way it is in humans, or can be. In humans, I think emotional intelligence, to some people it comes naturally. They kind of pick it up and it's more like a system one, they automatically react that way. And for other people, they have to learn it. So it's more of a system two thing. I have to be aware of, I shouldn't be saying this in polite company.
Well, kind of to that point, part of what I think of when you have let's say a psychologist, or I executive coach as my side gig. So when you're doing executive coaching, part of the reason you executive coach is because you implicitly care about the person in front of you, because you want to help them, because you have an understanding of what they care about, what goals they're holding, and being skeptical of should you be pursuing those goals and why are you pursuing those goals and all those sorts of things. So how can you build that into something that is completely rational in concept without the irrationality of the human component to it? That's something I'd be curious about, of understanding hey, if I am your personal assistant, how do I know that you are helping me in the right direction and not just encouraging bad behavior?
Yeah, so the question is how would the AGI be motivated to do the right thing for a person? Whereas you say that as a professional or as a coach or even right. Right. But you see, if you look at it from that perspective, is to be good at your job, you need to basically to be good at your job, you need to care about what people do, whether you emotionally care about it or not. I mean, that's more like a professional motivation. Is that the job you want to do? But that's a very human kind of thing. So I think an analogy here is a good psychologist doesn't actually feel the emotion of their patient, but they know how to respond to them. And in a similar way, an AGI will inherently be designed. The only product that we'll design and that'll get more engineering effort, more training, is a system that does a good job. And doing a good job is basically understanding what the customer wants. And if the customer is the personal assistant, the customer is the owner of it. So it'll be very much a matter of the system just being able to do a good job. But there's a deeper and very interesting issue here, and that is something that I spend a lot of time thinking about and writing about, and that is what I call rational ethics. And that is the idea that rationality fosters morality. And it's quite a complex and difficult thing to kind of convey, because it's a little counterintuitive. But so in addition to saying that an AGI has to inherently be good at doing what you want to do, otherwise it wouldn't be a good product. That's not, it's basically a bug. It's, the system isn't working properly if it doesn't do what you want it to do. Now, how will it prevent you from doing stupid things? And this is where rational morality comes in, because a lot of the things that we as humans do that that we regret or that are counterproductive, that are harmful to us, are due to one of three things. The first one is and I'll use the example here of 9/11 because everybody's familiar with that. So the first problem is that we tend to act emotionally. So 9/11, we've got to hit back at somebody. We've got to do something. Afghanistan, Iraq, whatever. You've got to hit back at something. It's emotional reaction. Now, an AGI isn't going to have that emotional reaction. So it won't fall into that trap. The second thing is we tend to make decisions with insufficient data because it's hard for us to get good data, and we also have the problem of what's the term? If it agrees with our preconceived ideas, Yeah. So again, 9/11, weapons of mass destruction. Yeah, check. Good enough. I don't need to dig further. Whereas an AGI would inherently, it'll be easy. Doesn't have a confirmation bias, and it can dig a bit deeper and say, well, is this actually true? Let me dig a little deeper. So again, it's more likely to avoid that problem. And the third problem is that we're not very good at rational thinking, at logical thinking. So again, 9/11, did we really think through the consequences of, going to Iraq? Is that actually, what's the end game? Would it actually serve our purpose? Does it even have a positive outcome? We didn't think this through of the consequences, whereas an AGI will be much better. It'll be a natural mode of operation. So A, it's not going to act emotionally. B, it's going to act with more information. And C, it's going to be able to think through the consequences of the action much better. So there are many ways, and that's what I call rational ethics, that rationality fosters better decisions or more moral decisions. If you just take morality as saying things that you regret doing, things that actually didn't foster human flourishing, that were anti-flourishing. So again, AGI will help us in that regard, and it's inherent in its nature. Other questions? Yes? Yeah.
Hoping you can comment on orchestration across these AGIs to, those godlike outcomes that you said weren't super likely, and I agree, for an individual unit perhaps not, but there are many godlike outcomes that we see, whatever, catching the rocket out of midair and you get your package in 2 hours or whatever, that are just the orchestration of human level intelligences. And so I'm wondering if you can comment on just the role that the orchestration across these individual units might play in the long term.
Yeah, so orchestration among AGIs, basically. When we talk about AGIs being able to do any desk-bound cognitive job, that includes administrators and managers. So there will be AGIs that basically are just good at doing the orchestration, and I firmly believe I mentioned briefly, with Singularity, we're not going to have godlike AGIs, but there's another related point to that is we're also not going to have sort of just one big AI, that sometimes people fantasize, whoever's got the biggest data center, the biggest machine, they're going to win, and they're going to have. That may be true for large optimization problems like weather prediction or nuclear bomb simulations or something. It's true for that. Whoever's got the biggest computer can do the best simulation. But for AGI, it's not going to be like that. It's going to be billions of relatively small AGIs that specialize and then collaborate. I don't know what the optimum size of an AGI will be, but at a certain point, it'll have too much information and become counterproductive. That'll be confused by the number of things it needs to take into consideration, and also from a physical point of view, at a certain size, you have limitations of just speed of light, of how much cache memory can you really manage and have. So there'll be physical limitations that'll dictate what the optimal size of an AGI is, but there'll also be cognitive limitations of what the optimum size is. So I see basically a huge number of AGIs, that will specialize, that will manage, that will orchestrate in a very kind of fluid way. Yes?
Follow up to that, do you think that there's to that limit within the AGIs and the potential growth, could quantum computing level that layer to have a much larger management?
Okay, where do quantum computers come in? So I think all indications are that if quantum computers are possible, and I think the jury is still out on that, whether they can actually scale and do useful things. But let's assume that they can. I think there's pretty much consensus that quantum computers will always be for optimizing, finding optimal solutions to data problems, essentially. So I see them being a tool that AGIs will use. Now, AGIs can help design quantum computers and, build them like basically scientists. But I don't see quantum computers by themselves becoming AGIs. They're not Turing complete, and they can't really, they can't execute algorithms. They can, I'm no expert on that, but everything I've read, there seems to be pretty much a consensus that what quantum computers will be good at is to find optimal solutions to particular problems.
Well, that's what I was referring to more.
Yeah.
So, like the use of quantum computing to find the optimal level of AGI.
Oh, okay. The question is, can we use quantum computing? Quite possibly. One of the problems that quantum computers, so the AGI will design the quantum computer, and quantum computer can help to optimize. Actually, that is quite possible that there's something like that, because an AGI will have a lot of free parameters that can be tuned, and there may be a way of using quantum computers to figure out what the optimal parameters setup is. Maybe. It's possible. All right. Any other questions?
Peter, I've got to give you a hard time. I can't leave today without giving you a hard time. So, I don't know if you know, Peter is, I think, must be a magician as a part-time job. Y'all may not have recognized it, but he kind of did the left hand, right hand. This is my last time I'm going to do this. I'm going to go off. Like, we're going to miss you. We appreciate all you've done. All of us that have been here for all of these sessions, they're very valuable, and we thank you for that.
All right. All right. Well, thank you. All right.
I certainly understand you have intentions that you have to pay focus to, but we'd love it if you would maybe have a happy medium, maybe do a podcast or something to share your knowledge, because you've got many decades of knowledge that we appreciate. So.
Well, I'm not going to disappear. So I actually do a lot of podcasts. I've done probably 100 podcasts now. So, and as far as the Austin community is concerned, I'd very much like to, keep in contact with people interested in AGI. So feel free to hit me up. And
you and Jay are going to Atlanta like next week or something, right?
What?
You and Jay are going to Atlanta next week?
No.
You've got a thing in Atlanta, I thought.
Oh.
I thought you were speaking. Jay.
Yeah. Tomorrow we have something, but
In Atlanta?
that's online.
Okay.
Tomorrow, the thing tomorrow is online. Yeah.
That being said, so,
Yeah.
good,
Well, if I'm in Atlanta sometime, I don't know about it. Yeah.
you said something like
Yeah.
the theme is AGI,
Mm.
and you talked about it earlier. I would say, this week I used Claude and I used ChatGPT to solve a couple of issues I was looking at. One was some coding, one was more in looking at different, just try to figure it out, but it's like, let me back up and say, do we need one model to solve everything? As opposed to if I'm looking at coding or I'm looking at solving another issue, I can flip a model. Like if I'm on my desktop, I'm trying to code something, I'll flip to this. If I'm trying to solve for another issue, I'll flip to another model. And is that not what we really want from AGI?
No, I mean, probably the one message, if there's one message I want to bring home here, is AGI needs to be able to learn in real time. And that's going to be a requirement. I mean, think about robotics as well. Imagine you have a robot in your home. It needs to learn about the pets. You just got a new puppy dog. How does it need to interact with that? Or the cousins come to visit. How do you deal with that? And I mean, there are things changing all the time that are unique to every situation. But that's true for programming. If you're implementing some software for a client, it's a particular requirement of the client you need to understand, and you need to integrate that with the knowledge that you have. So where large language models will be useful in the future once we have AGI is not really clear to me, of whether there'll be some specialized that they've been specialized for something. Certainly deep learning itself will continue to be useful. Whether transformer-based models, I'm not sure where they're going. I mean, image generation, video generation, they seem to be really good at that. So we'll probably have those kinds of models that we can then, but then it's a tool. It's a tool that the AGI will use that's specialized.
But you talk about everything. Every time I've been here, you talk about a PhD level of knowledge. Take your Harry and David example, or flowers.com example. That's a narrow focus, I would think. I don't need you to understand how to solve, other medical issues. I want you to solve my issues when I have all these thousands of people calling in wanting flowers or other.
Yeah, well, that is basically that blue layer that I said. So, I mean, the reason we could do Harry and David is I have many years of experience in call center automation, and prior to that, in my previous company, I had a lot of experience with just helping businesses with their accounting and with their inventory and so on. So that it's all that accumulated knowledge that I had, where I could then ask the customer the right questions of, what are your business rules and what is important, and I want to interview your call center manager, and what questions to ask the call center manager. So that kind of skill an AGI can train up, and then it can basically talk to the particular company and find out what's special, what they need to do, and use its knowledge combined with the specifics of that customer. But you'll also have a whole a large group of AGIs that specialize on customer service, and they can share their insights and their information much more effectively than we can. When I hire people for my company to try and impart my knowledge that I have in call centers and business, it's not easy. it's not easy. You know, there's a lot of stuff that if it comes up, I know, but I don't know to teach somebody, that. Yep.
I was going to kind of add to that. I think within your example, I was thinking about different ways that AGI could potentially help the individual user be more personal. Because I came from the medical field, and part of the issues that we have within the communication from client to medical personnel is what information do they remember, what information do they share for multiple reasons, whether it's they're ashamed of whatever conversation they want to have or anything like that. So you can have an AGI conversation. So say I'm a doctor and I have my AGI and you have your AGI. He's already communicated different, your diet, your actual diet versus, how much do you actually drink water, how much do you drink or partake in other things that could affect the decision and medical advice.
Yeah, actually an interesting dynamic, because there are certainly studies that show people are more willing to share stuff with an AI than with another person. And then, yes, let my AI talk to your AI kind of thing, and their motivation, they don't have an ulterior motivation. Their motivation is to help you with whatever you need help with. So I think that'll also be good. Yeah.
So I have
Yes.
So my question's kind of more around, because even he just mentioned like dating, right, or whatnot. So I feel like if you have an AI, like AGI, come to this consensus, like global equilibrium, right? Some stuff needs to be improved, the rest of the world kind of needs to settle in, but then you have ego, right, involved. And so some people know, hey, this is common sense, but I'd rather do this because it's like my self-interest. So how is it gonna, how would that kind of work out? Because you have advanced technology and then other places aren't necessarily adopting it at the same.
Well, I'm not sure what sort of concrete example is. I mean, yeah. Can you?
That's a good example. I would just say kind of like a cultural kind of boundary set, right? So let's just say if it's trained. Okay, well, I have this interaction, right? So I used to work and live in Alaska. So you have a lot of like the old, like the Nubian tribes or indigenous. The way that they go about life is like Hawaii and a lot of more rural places. They have a slower pace. And so the way that they see advancement and or equilibrium is different than what we would see it like in the US.
Oh, okay.
So then the meeting of the minds between like, I know that the AI just is saying this is the right path to go, but then you have your own personal ego that kind of drives different conversations.
Right. Okay. So I think what you're alluding to is if the AGI has a certain view of how you should live your life, but you're not on board with that, basically. Yeah. Well, that needs to be the skill of the AGI to know how much to push, or it's going to be tricky. I mean, but that's also like if you have a good friend or somebody in the family who does something silly. They get addicted to something or they really make bad decisions. How much do you push them to? Where do you stop and let people make the mistakes or do things the way they want to? All I can say to that, I don't know the answer. All I can say to that is we're not doing terribly well as humans on that. So hopefully AGI will just be able to do a better job at managing that. And clearly there are communities that will resist, that simply do not want this. They don't want AGI. And the extropian philosophy that I spoke about, which at the moment my belief is that an AGI will sort of come to an extropian type philosophy. I mean, I don't know. It might might tell me why extropian philosophy is wrong. When I get my AGI, it'll help me figure that out. But if it is an extropian philosophy, it is very much about self-ownership, that people should be in control of their lives as much as possible, but also take responsibility for those decisions. And to the extent that they want to use an AGI to help them, and to the extent that they use the advice of the little angel on their shoulder. But also there are always the two ways of looking at it. You can say, look at it as a little angel on your shoulder that you can ignore and let the devil in your head take over. Or you can think about it as an AGI really becoming an exocortex, an extension of your own mind. That basically you make more and more decisions that involve the AGI. So it really is, you're not fighting the AGI, it's part of who you are. That's what I say. But interesting times. Yes?
Are there any university or academic community doing AGI research not based on LLM?
Are there any universities, or is anybody doing research on AGI not based on LLM? Not that I'm aware of. Really, deep learning has sucked all of the oxygen out of the air. There's a monoculture. In fact, I can give you one specific anecdote here from my personal experience. We had a brilliant intern from Germany work in our company, and he really liked our approach of cognitive AI and so on. He was with us for 18 months and went back to Germany to do his PhD. Couldn't find a sponsor for cognitive AI. So 7 years later, he now got his PhD in machine learning, and he's lost to the cause. So that's pretty typical. No, I don't know.
Did Elon Musk ever mention or kind of like share some of his ideas about AGI? Because recently in some of his full self-drive program, right, his AI driving kind of thing, he kind of think that some of the advances are beyond the current state of AI. He said it's kind of like a mini AGI. Okay.
Does Elon Musk have any? Well, actually, interestingly enough, and I think I can share this publicly. I had a discussion with Elon a few months ago, about half an hour. In fact, what makes this interesting, it was on the same day that the European Union wanted to shut down Twitter, X, and it was the same day that he had his first rocket failure. The second stage failed on the same day. And that afternoon he still spoke with me for half an hour. So amazing guy that, he can, and he was engaged, and I explained our approach to him, that we use orders of magnitude less training and so on. So that's why he was interested in talking to me. So I could use the analogy of, at the moment we're basically building something like throwaway rockets. Large language models are built and then you throw them away. Surely you want reusable rockets, large language models. So he kind of liked that. But then I also tried to explain to him, he likes to think in first principles. He often mentions, you've got to have first principle thinking. So I thought he would understand that. So I said, our AGI approach is thinking in first principles, that you have to start by understanding what intelligence is to build a machine that has intelligence. And I lost him there, because he replied that, nobody can define intelligence. Intelligence is as intelligence does. And that's sort of fortune cookie philosophy, So clearly the cognitive psychology part was not something that resonated with him. You know, he's a hardcore engineer, and so I said, can I play with your system? So, you know, we're trying to build a demo that he can play with our system. But no, he does not have any idea right now other than scaling. And, you know, with this full self-driving, we just need more data. We need more data, more edge cases, more data. Now, for self-driving, that could work. I mean, it's not going to work perfectly, but it could work well enough that it drives better than humans. It's possible. But that's, again, even driving is not how we work. Just think of the example, you move into a new neighborhood. So you drive around the corner and somebody backs out of a blind driveway. Now, you learn. You now learn that when you go around that corner, there's a blind driveway there. His full self-driving will not learn that, you know. Will not learn where you can drive a bit faster, where you should drive a bit slower, unless there's a lot of training data, you know, for that. So that metacognition is just not going to be there in the full self-driving. But the brute force, you know, for that. And at the moment, he's still making progress with Grok. You know, Grok is getting better, and the next version of Grok will probably still be better than the one he has. But again, it's a road to nowhere. If he has to throw away $1 billion worth of training every time he builds a new model, and you know, we've just had the presidential elections here. The amount of change in our ecosystem is enormous. I mean, the world we lived in a week ago versus the world we live in now is very, very different. So you start training a model now, after the results are out, it takes 4 months to train the model, or whatever, 3 months, 6 months, whatever it is, many months. Your data cutoff is today. It's not going to have that knowledge. Now, it can do a search, it can do a Google search and get the latest information, but it cannot integrate, it cannot build an integrated model of the world we live in. You need a system that can learn incrementally. So, no, Elon Musk doesn't know that there is an alternative or a viable alternative to that. At the moment, still very much, you know, he just spent $5 billion in building a new data center, and I'm sure he's planning the next $10 billion data center already.
You got that information from the same part of a brain that told us when the Cybertruck was going to come out the first time.
Yeah.
He's autistic, and if you talk to an autistic person about psychology stuff, it would just go over their head.
Yeah, I mean, that's a problem we have when we talk to VCs, is, you know, the problem is, you know, we say, well, we have a better approach to get to AGI, and then they ask us, well, how many GPUs do you need, and, you know, what data are you going to use for training? And we say, no, that's not an issue. You know, we don't need a lot of data, and we don't need GPUs. You know, we use cognitive AI approach, and, you know, and then their eyes glaze over, you know, and it's, you just really can't get anywhere. It really needs to be somebody who wants to learn, and they have to unlearn a whole lot of stuff that they knew, you know. And for that takes time. You know, it takes time and it takes motivation. And typically VCs have the mindset, you know, they get thousands of people looking for money, and they reject 99 out of 100 or whatever the ratio is, and basically you've got like 3 minutes to convince them that, you know, this is worth spending more time on, and it's tricky. It's tricky. So if you know anybody with deep pockets or any influencers who are interested in AGI, that's the strongest thing, that how you can help us, and introduce me to them. To, you know, just have a chat, not about money, just for interest. Just if you think this is interesting, persuade them that they'd find it interesting to talk talk with me and learn something, maybe learn something about how to get to AGI.
Sounds like you have to convince Elon Musk. He just made $15 billion since the election, so in 1 week. So. All right.
Make an introduction.
Is it
Yeah.
fair to say that your cognitive architecture is significantly based on psychology? Because you've been talking about a lot of psychology impact, right? In your research, in your own study,
Yeah.
you put in a lot of things you get from psychology. So is it fair to say that your architecture is very significantly based on, psychological functions, as you
So is our architecture based on psychology? Yes. Really, the reason I spent 5 years literally studying different aspects of it is for me to deeply understand what makes what is human intelligence and what makes it special. And what psychology taught me, in fact, one of the things I can elaborate on is I wanted to understand what IQ tests, how IQ tests measure and how they work. And there's an interesting project I got involved with. I was still living in South Africa at the time, and a friend of mine did a PhD to develop a new psychology test, new IQ test, because black people in South Africa did very poorly on IQ tests. And the main reason for that is that IQ tests have most IQ tests have a significant cultural bias. So black people with a different cultural upbringing just inherently didn't do well on IQ tests. So she developed what's called a cognitive process profile. It's not strictly an IQ test, but it measures your cognitive ability and it measures your cognitive potential. So it measures how good your cognition is currently, but it also pushes you in different directions in different each dimensions and kind of gives you an idea of what your potential is in cognition. And I actually spent about 8 months or so working on the project, actually computerizing this test. And that I gained some good insights on that, on what is important in intelligence and measuring it. And one of the things I learned from that is how important metacognition is, because we found that the test measured about 100 different dimensions, had about 100 different dimensions that were measured during the test. And there's one group of dimensions that are metacognitive dimensions, which is basically your ability to apply the right cognitive strategy to the problem. Some problems require you to think logically, other problems require you to rely more on memory, some problems require you to think more intuitively about them. They don't have a logical solution, they have more of an intuitive solution. And then some problems have no solutions, and metacognition also, you need to realize that you probably can't find a solution to it. So people who have strong metacognition basically have high IQ. So that was, one of the insights I got from studying psychology is the importance of metacognition and what metacognition entails. But also I learned, I did a lot of research on animal studies and what animals are capable of and what animals aren't capable of. There were experiments where chimpanzees were raised with a human family, together with babies, as human babies. And they actually developed quicker than the human babies up to an age of about 18 months or so. And then they topped out. The chimps topped out. They couldn't develop beyond that. And then the human babies overtook them. So there's so many things that I learned from studying cognitive psychology. When do children develop theory of mind? The different psychological theories like Piagetian development and so on. And some of those, were just turned out not to be relevant for AGI, and other things turned out to be turned out to be relevant. So a combination of epistemology, the theory of knowledge, and importance of concept formation and how we can learn things, where free will comes in, what consciousness is, both from a philosophical point of view and from a psychological point of view, was I think really important for me to sort of come up with the design of AGI.
Would you be open to do, or maybe you have already done, beyond psychology, but look into neuroscience, like the latest? I know that the human brain is so complicated that we still know very little about it.
Yeah.
But if you look into, let's say, the LLM, it's based on deep learning, and that's based on neural networks. So it's basically trying to find a path to AI through anatomical means.
Yeah.
Anatomy of the brain.
Yeah.
But are there any recent advances in neuroscience that give us further insight?
Yeah. So where does neuroscience come in, and how does neuroscience inform AGI? I did also study that quite a bit of that, and especially AI research. There was in the 90s there was quite a bit of research done in trying to simulate actual biological neurons and build AI that way. The conclusion I came to is that's really the wrong way of looking at things, the wrong level of looking at things, that we need to understand the mind much more than we need to understand the brain. So there's some inspiration we can get from how the brain works. And we have Jeff Hawking, he wrote a book on intelligence, and there's some kind of deep learning algorithms that came out of that are quite useful. But I don't really think that we can learn all that much from neuroscience, or that new insights from that will really help. And to kind of explain that a little more, is the analogy that I use here is that we've had flying machines for over 100 years now. We built the first aeroplanes 100 years ago. So we've had flying machines for 100 years. We're still nowhere near reverse engineering a bird. What we're trying to achieve there is flight, effective flight, and being able to transport, for us to fly in the air, to transport things and so on. So planes are the right solution. And while they borrow some aspects of, how birds fly in the aerodynamics, it's really not reverse engineering a bird at all. I think of AGI in the same way. We want thinking machines. We want machines that can think, learn, and reason the way humans do. But we fundamentally have a different approach to it. We're not using evolution. Evolution built our intelligence, built our brains, basically. And we don't have biological material. We are not using evolution, we are doing engineering, and we don't have biological material, we have basically silicon chips. So it's a very different material, it's a very different approach. So reverse engineering the brain is not what we're doing, it's reverse engineering the mind or mental processes. So I don't see neurobiology really helping us with AGI.
I just wanted to add a little layer to that from my perspective. The neuroplasticity that we have in our brain is ultimately done by neural networks. So digging deeper than that would probably defeat the purpose, just like you said, the reverse engineering.
Yeah, and the other thing is, the way the brain develops significantly physically as a child learns. We know that a child starts with a lot more neural connections and actually prunes them. We lose a lot of those neural connections. That's not really the way we're going about it with AGI. We're not starting with massive amounts of connections and then pruning them, and we don't have the physical development of the brain. So there are just a lot of differences. What's the time now? 7:41. Okay. All right. What else? Yes.
If we have people who would be interested in probably having a conversation with you, what's the best way to facilitate that?
Just contact me. I'm on LinkedIn, Twitter, or just peter@igo.ai. So, yeah, anybody seriously interested in, and if you just want to, I don't know, have lunch or something, if you have some ideas you want to, that's my life. That's what I'm passionate about. I spend probably 13, 14 hours a day working on AGI, so 7 days a week, so that's my life.
Is there, have you talked to government types, and then is there anyone that you would prefer not to work with, or like ethically or any boundary-wise?
Yeah, so have I worked with government types? No, I've not. Unfortunately, my experience in trying to work with government is very limited. And the few experiences I've had, it's always been consultants who say, pay me $30,000 a month and I'll connect you, I'll give you contracts and so on. So I've not had a particularly good experience with it, but it's been very limited. And no, I don't have fundamental. Again, my view is that AGI will hopefully also help the military make saner decisions, better decisions, and ultimately not going to be able to keep AGI out of the hands of the government, even if you wanted to. So rather kind of have as much control over that than not. But no, I don't have any limitations other than I don't want to deal with shysters.
Are there other startups that are doing AGI well, or they're running into the same roadblocks that you guys are?
Well, as I said, there's virtually nobody else working on, and I just heard that elemental cognition apparently bit the dust. In fact, I don't even know if the Intel project is still going, because a few months ago Intel laid off about 10% of their staff. So it's possible that that project also isn't around anymore. I do keep in touch with AGI Society. There's an AGI conference that's run every year. And I wasn't at this year's conference, but I was at last year's conference in Sweden, AGI conference. And there's probably only one well-funded project from that AGI society. The rest are just university projects, PhD projects, that try to solve one particular narrow problem or beat some benchmark or something, and then that project goes away when people get their PhD or get their degree or whatever they're doing. So most of the stuff that's happening in the AGI community, sort of society, is not a plan to actually get to human level AI. The one exception is Singularity Net, which is Ben Goertzel. In fact, three of us coined the term artificial general intelligence in 2002, Ben Goertzel, Shane Legg, and myself. Now, Shane Legg is the co-founder of OpenAI. Sorry, not OpenAI, DeepMind, the co-founder of DeepMind. And actually, Shane Legg worked for me in 2002. He was on my early AGI company. So within the AGI, so Ben Goertzel's Singularity Net got crypto funding, so they raised about $30 million or so. I'm not sure how much, but at least $30 million with crypto. Now his idea is basically build an ecosystem that's sort of controlled by blockchain, that's supposed to be an ecosystem of different AGI approaches or AI approaches. Now, I don't really see that working. I don't see a whole bunch of narrow AIs turning into AGI. And yeah, but that's probably the only kind of well-funded project that they believe they have a path to AGI. I just don't believe that it's very viable, but I could be wrong, you know. So that's the only AGI project that I know about that has sort of any real chance of viability. You know, there are a lot of big data, deep learning, machine learning related projects, but that sort of supposed to go to AGI. But then again, you know, the dirty little secret is they actually don't have a plan to get to human level AGI.
One of the open AI guys was sort of asked about this, like the statement that like LLMs aren't a path to AGI, and his response was, well, or like next token prediction is not a good path to AGI. I think it was the main scientist there, and his response was, well, you could just ask for the next token that a specialist would indicate, or the next thing a specialist might do. I was just wondering if you could comment on that, and if you think that's a cogent answer.
Well, you know, I think there are lots of things you can do with large language models, and people are. I mean, there's an enormous amount of money. There are literally hundreds of billions of dollars flowing into the whole ecosystem. So they're obviously doing all sorts of tweaks and, you know, ways of improving the system, trying to get them better, prompting it, you know, in different ways. But if you go back to my slide of the 7 deadly sins, it's the wrong approach for so many different reasons. But you don't see companies that have been funded to work with big data, and that are still up to now have still been seeing improvements and certainly more money flowing into it. They're not going to just abandon what they're doing and do something completely different. And you know, they just typical lessons from business. I mean, how could little Amazon, when it started, little Amazon bookseller, how could they ever compete with Walmart, you know? Or Google, how could little Google compete with the established search companies, you know? You see that again and again. You know, the big companies are like oil tankers, you know, they can't just pivot. The whole culture, the management and everything is so committed to the approaches that they have. It's extremely unlikely that they will change. What is that?
Innovator's dilemma. Now they have a bunch of LLM customers. They've got to keep those customers.
Yeah, sure. It's a momentum that you've got. It's what you promised your investors, and as you say, you have existing customers, and there are all sorts of reasons why AGI is much more likely to happen from some outside. Somebody who has a kind of fundamentally different approach. You know, even Jan LeCun, who I quoted as, you know, as saying he's totally adamant that large language models are an off-ramp to AGI, a distraction, a dead end. But his own approach, he actually believes that, like I think somebody mentioned, is you need much more visual much more like a baby interacts with the world. So he sees massive amounts of visual information as the path to AGI. Now, he doesn't have a clear technical approach to that, but that's sort of his general direction, which is still very much large data, big data, but focused on vision. So there's some sense in that it has visual grounding, that the knowledge will have visual grounding and interaction. But again, he's totally focused on big data approach and not incremental real-time learning. All right, well, unless there's some other burning questions, I think we can, I don't know, still some cookies left there, a little bit. I don't want to take them home, so so please clean them up. All right, well, thanks for coming. Well, I think we had a good meeting and good questions.